Hi there, in this video I'm going to do a past exam question on integration. So let's take a look at the question. Question number 2, the curve with equation y equals 1 over 3 into 1 plus 2x, where x is greater than minus half, is shown in figure 1. The region bounded by the lines x is equal to minus a quarter, x is equal to half, the x-axis and the curve is shown shaded in figure 1. This region is rotated through 360 degrees about the x-axis, and in part A, use calculus to find the exact value of the volume of the solid generated. So let's think about this problem. Let's get back to the paper and pen. Now, in order to work out the volume of solid revolution V when you rotate a region about the x-axis, remember this formula. So the formula goes like this. So the volume of solid revolution V about the x-axis, and the formula is V is equal to pi into the integration of y squared with respect to x between the given limits. So if you're unaware of how to calculate the volume of solid revolution, I have created a video and I'll provide a link to the video where I explain the method along with some additional examples, and I'll provide a link to the video as I say in the description below. So going back to the question, now we have the equation of the curve y. Y is 1 over 3 into 1 plus 2x. And we also have the limits of the integral. The limits are x is equal to minus a quarter and x is equal to half. So let's go back to the paper and pen. So let's make a note. Y is 1 over, so this is the equation of the curve given, 3 into 1 plus 2x. And we have the limits x is equal to minus a quarter and x is equal to plus a half. So let's incorporate this data in the formula to give us v. V is pi into the integration. So the limits are minus a quarter and half. Y is 1 over 3 into 1 plus 2x. Let's close that bracket, not forgetting to square with respect to x. So let me multiply, let's get rid of the brackets. So when we get rid of the brackets, we'll have pi into the integral between limits minus a quarter and a half. And if I square 1 over 3 into 1 plus 2x, 1 squared is 1 on top, divided by 3 squared, which is 9, 1 plus 2x to the power 2, let me write it as this, 1 plus 2x to the 2 with respect to x. So this is what we have so far. Now let me rewrite this integral as v, which is pi, so pi. I'm going to take a common factor of 1 over 9 out of the integral. So remember, you can only take constants out of the integral. So if I take a common factor of 1 over 9 out of the integral, along with the pi, it will be pi over 9 into the integration of. And further to that, I'm going to bring the 1 plus 2x squared up. So if I bring that term up, I'll have 1 plus 2x to the power of minus 2 with respect to x, between the limits minus a quarter and a half. Now to integrate such an integral, there is a result. So let me give you a result. You can use this result for ax plus b to the power of n. So I have created a video explaining this result and how it's derived, and I'll provide a link to the video in the description below. But let me talk to you briefly about this result. So if you're integrating such a term of the form ax plus b to the power of n, now the idea is we add 1 to the power to give us ax plus b to the power of n plus 1. So add 1 to the power. divide by the resulting power, which is n plus 1, but you also divide by the coefficient of x. So the coefficient of x is a, so divide by a, and let's just add c for completeness. So once again, I have created a video on this and in this video I went through a lot of examples explaining how this result is applied, and I'll provide a link to that video in the description below. So let's go through the approach with this integral here. So we have v, that is pi over 9. So let's keep that outside. And remember the approach. So we have 1 plus 2x. So that is of the form ax plus b. The idea is to add 1 to the power. So minus 2 plus 1 is minus 1. Divide by that resulting power of minus 1. But remember, you need to divide by the coefficient of x. So the coefficient of x is 2. And not forgetting the limits. Limits are minus a quarter and half. So let's tidy this up. So we have pi over 9 outside into, so we can rewrite this as, so minus 1 times 2, so that is minus 2. So let me keep it as minus 1 over 2. And the 1 plus 2x to the power of minus 1, let's bring that term down to make it minus 1 over 2 into 1 plus 2x. So let's include the limits, which are minus a quarter and half. So I've rewritten this term in this form. So if we replace the limits, so upper limit replace first, so upper limit is half, we'll have pi over 9 then into minus 1 over 2 into 1 plus 2 of x, which is half. So that is what you should have upon replacement of the upper limit, minus pi over 9. And upon replacement of the lower limit is minus a quarter, we'll have minus 1 over 2 into, let's open up another bracket, 1 plus 2 into x, which is minus a quarter. So that is what you should have upon replacement of the lower limit, which is minus a quarter. So let's simplify. Let's simplify both terms in the brackets. So if you simplify this term and multiply by pi over 9, you're going to get minus pi over 36. So simplify this term, multiply by pi over 9 should give you minus pi over 36. And if you simplify this term in the calculator, and if you multiply by minus pi over 9, you'll end up with plus pi over 9. So that is what you should have as part of the simplification process. And if we take a common denominator, so if you take a common denominator of 36, the answer is going to be 3 pi over 36. And as 3 goes into 36 12 times, you should have an overall answer of pi over 12. So it's pi over 12 units cubed. That is the volume for the first part, part A. So we have another part to do, so let's get back to the question. Prior to part B, figure 2 shows a paperweight with axis of symmetry AB, where AB is 3 centimeters and A is a point on the top surface of the paperweight, and B is a point on the base of the paperweight. The paperweight is geometrically similar to the solid in part A. So that sentence is very important to this problem. In part B, find the volume of this paperweight. So let's have a think about this. So we have AB, and the length of AB is given as 3 centimeters. So bear that in mind. we calculated the volume of solid revolution in part A. So if you visualize the volume that we've worked out, and if you flip that volume to the side, you're going to get a diagram such as this as the result. And if you picture this, if you picture the height of this shape created, the height will be the half, which is the top part, plus quarter, the bottom part. And if you sum the half, the top part, with the quarter, the bottom part, that comes to 3/4. Now I'm looking at 3/4, and bearing in mind, according to the question, the shape in part A is geometrically similar to the paperweight in this particular part. Now that is very important because we can use this 3/4 as well as AB, which is given as 3 centimeters, to work out the scale factor. So let's get back to the paper and pen. Let's make some notes. So AB given in the question is 3 centimeters, and this is for the paper weight. And in this case, when we looked at that diagram, which is flipped to the sides, we had a height which is 3/4. Now using that, we can work out the scale factor. So let's work out the scale factor since they're geometrically similar. So the scale factor will be the 3 centimeters for the paperweight divided by the 3/4. And 3 divided by 3/4 gives us 4. So that is a scale factor. Now, if we go back to the question, bearing in mind that these shapes are geometrically similar, then let's go back to the paper and pen to work out the volume. So the volume of the paperweight. All we need to do is we need to cube the scale factor since we're working out a volume. So if we're working out an area, for example, then we square, but since we're working out a volume, we're going to cube. And we're going to multiply that cubed scale factor by the volume that we've calculated. So the volume that we calculated in part A, if you recall, so let's remind ourselves, is pi over 12. So if we multiply by pi over 12, we're going to get the volume of this paperweight. So 4 cubed times pi over 12, that should give us 16 pi over 3. And it's 16 pi over 3, the units are important, the units are centimetre cubed. So I hope that makes sense. So that completes part B, and that sadly ends this video. So I hope you enjoyed this video. I hope you found this video helpful. If you did find the video helpful, a like rating is very much appreciated. Do plenty of practice related problems, and I hope to see you again. Thank you.